All right. Hi, physics. Mr. Janowski here. This is Chapter 4, Homework 1, Problem 1. So Alice drops a penny off of a roof from a height of 15 meters. Part A, how long does it take to reach the ground? And there's your answer. And B, what's its velocity when it gets there? So we start off all problems the same way. We always start off with this. Whoop. Step huh. So step huh means make sure you understand what the question is and what you're looking for. So how long? How long does it take? So how long in this context means time. So the thing we're looking for is time. So t equals question mark, and the units for time will be seconds. So the next thing we do all year long, step 1 is to make a sketch. So let me give you a Roman numeral 1. So our sketch, what are we drawing here? All right, Alice is standing on a roof. So here's some kind of building. Here's Alice standing on the roof. Well, that's a terrible head. Okay, let me draw her head again. A little bit better. So I'm a little bit rusty at using the Wacom tablet here. All right, so when you make a sketch, it's important that your sketch starts where your problem starts and it ends where your problem ends. So she's going to drop it off of the roof. So here's the beginning of our situation. There's a penny, and it's not moving initially. She's just dropped it, so it's not moving at all. And then it's going to go down. And then the end of our problem is when the penny is right about to hit the ground, which, all right. And rusty with the Wacom tablet. And at the end of the problem, the penny will be moving. So it's right about to hit the ground. It's moving, so you have to give it speed lines. So that's what's going on. And what do we know? We know that it's a height of 15 meters. So, whoop. That's a reasonably good bracket. So this is a height of 15.0 meters. So I could add more to the sketch, but I don't really need to. That's enough. Now, step 2 in a kinematics problem is the variable bank. So here's a Roman numeral 2. What a sloppy 2. Okay, that's a 2. All right. So when you're doing your variable bank, start off by writing just the blank variable bank. So the things we want to know are y initial, y final, v initial, v final. Sorry, that's an equal sign. A and t. So we have to figure these things out. Some of these things we will know, some of them we won't know, and we'll fill in with a question mark. So y initial. Let me try to make this look slightly more like a y. I don't know if that looks more or less like a y, but we'll go with it. So y initial, what height are we starting at? In the kinematics problems, just always make y initial or x initial, just always make that one 0. So 0 meters. So what that means is this height right here that we're starting at, we're going to call it 0 meters. Now, y final is the height that this thing ends at. So that's down here. So this height, it's 15 meters below where we started. And where we started, we're calling 0. So we have to call this minus 15. Minus 15.0 meters. So minus 15.0 meters. I lost the decimal point. Okay, there's the decimal point. Okay, so V initial. How fast is the penny moving at the beginning of the situation? Well, Alice has just dropped it. So it's not moving at all at the beginning of the situation. Notice if we look at the sketch, there's no speed lines. So what is V initial? 0 meters per second. So this is very common in these kinematics problems. And nowhere in the problem does it say explicitly that V initial equals 0 meters per second. But it does say that Alice drops the penny. So you can assume if she just drops it, she doesn't throw it down, she doesn't throw it up, she just drops it, she just lets it go. So at the start of our situation, the instant the penny leaves her hand, it's not moving yet. So that's 0. V final is the velocity at the end of this situation. So that's right before the penny hits the ground. So notice there are speed lines, so it's definitely moving. So this is not going to be 0, but we don't know what this is yet. So we're going to call this one question mark meters per second. And A, what is going to be our acceleration here? This is a free fall problem. So A is going to be lowercase g, the acceleration due to gravity. And that's the number right here. Whoop. you will, whether you like it or not, you will eventually memorize that number, minus 9.8 meters per second squared. And then we get to t. How long does this take? We don't know what this is. So this will be question mark seconds. In fact, in part A, this is what we're looking for. So we've done step 1, step 2. The next step is step 3. So step 3 is a lot like step Just remind yourself what thing you're looking for. So step we're looking for time equals question mark seconds. So step 3 is just this. So it may seem odd that we even have to do this step at all, but it just leads so nicely into step 4 that we're going to do it. So yeah, there's step 3. Step 4 is to pick an equation. And there are 2 conditions for picking an equation. The 2 conditions are, it has to have the thing we're looking for, so it has to have a t in it. So if we look, the first equation has a t, the second one has a t, the third one doesn't have a t. So we know right off the bat it's not going to be the third one. And the fourth one has a t. So at this point, it could be 1, 2, or 4. Now, the other condition is we have to avoid any other question marks because we can only have one unknown in our equation if we hope to solve it. So the other question mark we have here is v final. So I can't use any equation that has a v final in it. So the first one has v initial, but not v final. Okay, so the first one might be the one. The second one, okay, there's v final. So it won't be this one. And the third one, okay, there's a v final, so it won't be this one, which means the only equation we can use is the first one. And the first one, the way it's written on the page, is in terms of x's, but I know this is an up and down kind of problem, so I'm just going to switch everything to y's. So what that means is delta y is equal to v initial t plus 1/2 a t squared. All right, now I have done enough kinematics equations in my life that I have memorized the kinematics formulas, and I know them by number, and I know all that stuff. You don't have to memorize these things. These things will always be there when you need them. So at the footer of the page of the homework, on the first page of the homework, things like that. You don't have to memorize them. I've done enough of these. So yeah, my pro tip is, are there any useful zeros that we can use to eliminate terms? And it turns out in this case there is one. So v initial times t. Well, we know that v initial is 0. Okay, so 0 times t is just going to be 0. So you can write that this way. Boop. So that goes to 0. And then that whole term is going to go away. That doesn't leave us the t. This is multiplication. So 0 times something, the whole thing goes away. So I'm just going to rewrite this. Delta y is equal to, and I don't need this term anymore because that's just 0. So 1/2 a t squared. So the equation has gotten a little bit simpler. We lost one of the terms. What color? I guess we go back to black. So step 5 is do the math. So the math means, just solve for the thing we want. The thing we want here is t. So the name of the game is to get t by itself on one side of the equal sign. So if I start here, okay, delta y equals 1/2 a t squared. Well, I don't like this half. So the first thing I'm going to do is multiply both sides by 2. When I multiply both sides by 2, on the left side, that's going to give me 2 delta y. My handwriting is very sloppy with the Wacom tablet at this point. And then on the right side, when I multiply 2 times 1/2, that just becomes 1. So 1 times a t squared. Well, I don't have to write the 1 because 1 times anything is just the thing. So on the right side at this point, I have a t squared. So I'm getting closer. Now I want to get t by itself ultimately. So I'm going to divide both sides by a, and that will give me 2 delta y over a on the left, and this is equal to t squared. So I'm getting much closer. So the last thing I need to do is take the square root of both things. Boop. So take the square root of both things. And I'm going to switch left and right. So on the left now, we're going to have t is equal to, okay, because it was t squared, when you take the square root, it could be plus or minus. I got to put the plus or minus in here. Plus or minus, that's a terrible minus. Plus or minus. Still a terrible minus. Undo. It's not undoing. Right, whatever. That's a plus or minus. The square root of 2 delta y, that's a delta, over a. Okay. So I've done it in letters as far as I can. Now I have to put in the numbers. So this is equal to plus or minus the square root of 2 times delta y. Okay, so delta y is always y final minus y initial. And this is why we make y initial 0. Because y final is minus 15.0 meters minus y initial, well, that's just 0, which means delta y is just going to be y final. So this will be minus 15.0 meters. And all of this gets divided by a. And a is g, so it's minus 9.8 meters per second squared. Okay, so if you do this, if you've done enough of these problems, you can do all of this in your calculator all in one shot. But let me do it, a little bit step by step. So this would be equals to plus or minus the square root of, 2 times minus 15 is going to give me minus 30.0 meters on the top. Woo, that's awful. Wacom tablet so I could write so nicely, and it's not really working out that way. Minus 9.8 meters per second squared. Okay. So that, again, if I were doing this myself, this would give us t is equal to plus or minus the square root of 3.06. And the units we would have left at this point are seconds squared. And your answer is not 3.06, so don't stop at this point. You've got to take the square root of that number. And if you ask the calculator for the square root of that number, it's going to tell you, it's not going to tell you the plus or minus part, 1.75 seconds. So at this point, technically, we have two answers. Which one is it? Is it plus 1.75 seconds or minus 1.75 seconds? Minus 1.75 seconds would mean that amount of time before our problem started. So in this case, that's a meaningless number. That is no physical reality here, really. So the final answer is t is equal to plus, so I'm not going to write the plus. Come on. 1.75 seconds. And then you put a box around it to let your physics teacher know that this is your final answer. And then at the end, of course, we've got to do step, Oop. Come on. Hopefully I get better at doing this stuff. Come on. I'm trying to draw an ellipse here. That's terrible. ... So step, does this make sense? Well, first of all, did we solve for the right thing and did we give it the right units? So go back to your step, So step, we were looking for t and we wanted units of seconds. So we did solve for t. We have it in units of seconds. So far, so good. Now, does our number make sense? 1.75 seconds. So if you dropped something from a height of 15 meters, and 15 meters is about 15 yards, so it's about 45 feet, does it make sense that it might take 1.75 seconds to reach the ground? So 1 Mississippi, 2 Mississippi. Okay, that's about 1.75 seconds. That seems like a reasonable time. So that's probably right. So we give it a check. So that's how you do part A. So I guess I'll keep going and I'll do part B here. So part B is what's its velocity when it gets there. So clearly I'm out of space on this board. Fortunately, I have another board. So yeah, what's its velocity? Oop, where's my cursor? When it gets there. So for part B, step, Step, What are we looking for? We're looking for a velocity, and the velocity when it gets there. So that's the velocity at the end of the problem. So that's v final. So v final is equal to question mark meters per second. Now, step one, of course, is make a drawing. But in this problem, and this won't always be true, but in this problem, part B refers to exactly the same thing as part A. So I don't really have to make the drawing again. I remember what it looks like. So save myself a little bit of time. I'm just going to write same as part A. Okay, not so bad. Step two is the variable bank. So let me quickly draw in the blank variable bank. Y initial equals Y final equals, whoop, V initial equals, V final equals, A equals, come on, and T equals. Okay, now because this is just, the exact same situation, this variable bank will look, exactly like this one that we just started with, only with one other thing. We just figured out what time is equal to. So yeah, we earned this number. We worked for it. We earned it. So we have the time. So when I go to fill in this variable bank, it's going to be exactly the same thing as before, only time is no longer question mark seconds. Time is now 1.75 seconds. So let's see. Y initial, again, that's always going to be 0 meters. Y final was minus 15.0 meters. V initial, again, Alice just dropped the penny, so it wasn't moving initially. So 0 meters per second. V final, well, this is what we're looking for, actually. So we don't know that one. Question mark, meters per second. A is still G. So it's minus 9.8 meters per second squared. Again, meters per second squared are your units for acceleration. And T, again, is no longer a question mark. T is now 1.75 seconds. So on to step 3. What thing are we looking for? We're looking for V final. It's actually the only question mark we have here. Whoop. So V final is this. Put a circle around it. Okay. So we've got that. On to step 4. Step 4, we have to pick an equation. And again, your two conditions are it has to have the thing you're looking for. So it has to have a V final in it. So the first equation, no V final. So it can't be that. Boop. Second equation has V final. Third equation has V final. Fourth equation has V final. So at this point, all of these things are going to work. The second condition is you have to avoid any other question marks. And at this point in the problem, we don't have any other question marks. We know all of the other variables that are in our variable bank. There are no other question marks, which means we could use any of these. So when you can, it's usually best to use the second equation. This is the simplest one. So for step 4, pick an equation. Yeah, whenever you can, use number 2. Second equation is the best one. V final is equal to V initial plus AT. Okay. Do we have any useful zeros? We do. V initial is 0 meters per second. So that means this guy just goes away. Okay. So that gives us V final is equal to AT. So on to step 5. And step 5 is the math. So when you're doing the math, keep the problem in letters for as long as you can. And try to get the thing you're looking for by itself on one side of the equal sign. And lo and behold, we're already there. We want V final, and V final is already by itself. So at this point, we can just plug in the numbers. So V final is equal to minus 9.8 meters per second squared. And a little note here, I will usually include, unless I'm running out of space or running out of time, I will include the units of all of my things throughout the entire problem. So even here in the middle. I don't actually care if you do or not. It's a good idea to, but I wouldn't deduct anything if you didn't do it. As long as you have the units in your final answer, that's fine by me. But anyhow, I usually include them. You can catch some mistakes doing it this way by always including them. So if we do this, what number do we get? So ask your calculator. Minus 9.8 meters per second squared times 1.75 seconds. And you should get 1.71 meters per second. And then you put a box around it to let your physics teacher know that this is your answer. And then at the end, of course, step, Oh, I see what I'm doing. Oh, stop writing. All right, on the Wacom tablet, there's a little button that if I push it, it brings up some other functions, and I don't want those functions. Okay, anyhow. Step, think about your answer. Does it make sense? Okay. Well, first, did we solve for the right thing? So go back to step, Step, we were looking for V final in units of meters per second. That's what we have. V final, meters per second. So far, so good. Does our answer make sense? It's negative. Does that make sense? What does negative even mean in this context? We're doing an up and down question. So negative means it's going down. Does it make sense that our penny has a negative velocity, that it's going down at the end of the situation? Yeah, you dropped it off the roof, or Alice dropped it off the roof. And then finally, is this a reasonable number? So 17.1 meters per second, or negative 17.1 meters per second. Bloody cheetah. How fast is that in miles per hour? Well, 17.1 is about 17. If you double 17, you get 34. So that means this penny is going about 34 miles per hour. Does that make sense? Well, try to think. If you drop something off of a roof from 15 meters, which again is about 45 feet, that's fairly high. So if you drop it from that height, it does make sense that it could be going about 34 miles per hour. So this is a reasonable answer. So you give it a check. So yeah, that's how you do a one-dimensional kinematics problem. And hopefully you guys found that helpful.